Hi, Omar from APSoft here. In this video I'm going to show you how to set up and run a static analysis optimization using Cortime. For this we're going to use this bracket that is part of a race car. Shafts go through these two small holes here while forces are applied in these small holes. We can take a look at the static analysis and we can see that these two are fixed because of the shafts going through while the forces are applied in these ones. Now, our main goal here is to reduce the mass of the bracket while keeping the von Mises stress in this inner phase under 250 megapascals. For that, we have set up 4 equations. If you don't know how to set up equations in SolidWorks, you can always check out our core concept videos. So if we take a look at the equations folder, we here see A, B, C, and D equations. If we want to take a look at them, we can open our sketches. Here we have A, that is this thickness, D, this thickness, then we can open this one, and we have B between this line, and C between these two lines. Now, once we have the equation set up, we have to take a look at the sensors. The same, if you don't know how to set up a sensor, you can always check out our core concept videos. We have set up 4 different sensors. A model maximum von Mises stress, the whole bracket, an in-phase maximum von Mises stress, in-phase average von Mises stress, and the mass of the bracket. Once we have the equations and the sensors set up, the next step is to set up the optimization in the Cortime window. Now the first thing we're going to do is, into the optimization variables, we're going to drag and drop our equations to turn them into variables. So we have A, B, C, and D. This is the current value of each, and we're going to set some ranges in which the algorithm is going to work. And now, as always, we're going to click on the arrow and run the design checker to see if the file can rebuild in every step we have set. Well, we can see here there are many mistakes. So here we can see fillet doesn't work, cut screw doesn't work, there is a tension marking there. Now I did this on purpose to show you how design checker works. I know already what is the problem. The problem here is that the range, the upper limit in the A variable is too high for our design. So I'm gonna reduce it and then I'm gonna run the design checker again and we'll see how this time it works. In your case, the ranges will depend on the manufacturing necessities that your part has. So it's up to you to select them using the help from the design checker. Okay, we have here the design checker has run and everything is correct. So we're gonna go for the next step, that is the optimization objectives. So for that, we're gonna use the sensors we previously created. In this case, we're gonna use mass, and the type is gonna let it as minimize, medium priority. We're gonna go for in-phase max. This is our main goal here, so we're gonna go and minimize until, because we want to keep that number until a certain threshold. We're gonna give a very high priority, because when we are working with static analysis, usually the maximum stress supported by whatever we're designing is the limiting factor. So we're gonna go with a very high priority, and we're gonna set our target at 250 megapascals, because when we set the sensor, we selected megapascals as units. And for the last one, we're gonna use the model max, but this time we're not gonna assign any modifying type. We're gonna go with observe, because we want to track this value and be able to watch it on the graph, but we don't want to use it as a factor. Now, once we have set the setup window, we can go to the optimize window. In here we have the display settings. We're gonna put our variables also, so we can have them on the graph. In here we have to select the y-axis for each. In this case, we could actually share the axis for most of them, since we're working in the same more or less scale and magnitude order, but we can also set an axis for each one. It's not a problem in there. And then we will be sure that they are properly scaled respect to each other. And now for the optimization settings, we're gonna let most of it as default. We're working with several objectives, so we have to let the multi-objective algorithm. We have no clue how close we are to the correct solution, so our solution space should be unknown. The same goes for the preset. We're gonna let regular optimization because we are not sure how many run steps we should accept, so we're gonna let Cortime deal with that. And for the number of sessions, we're gonna run 3 instead of 1 because we want to make sure that our solution is correct, and the best way to check that is to check between different sessions. And for the number of iterations, we're gonna go with 650. Once this is done, we can go to the options window, general preference settings, and we're gonna click on always show message box because we want to see the remaining time and iterations during the simulation, and the display function value column because it will showcase the current value of every objective and variable we're working with. And once this has been set up, the next step is just run the optimization. Once the optimization process has finished, we can take a look at the results. Let's observe first the part. We can see that this connection here and the inner connections have been thinned down by the mass reduction process. Now we take a look at the graph, and we see there is a huge difference between the first iterations and the rest of the progress. If we zoom in using the right click, draw a rectangle, we see that the first 4 iterations look very different. That is because of the algorithm's own nature. In the beginning, the steps it takes are random because it's exploring the solution space. Once it gets to a point in which it considers it's good enough, it starts optimizing. To go back to the original view, we can right-click Auto Scale once, and we see the whole process again. In here we have chosen not to show the variables because our main interest is in our objectives. So we have the maximum inside the face on green, on blue we have the maximum general, and then we have the mass on red. If we look at how the mass has behaved, we can see that it has gone from the beginning as ups and downs, but in general it has gone down completely. So from around 0.75 to less than 0.60. If we look at the green part, that is the in-phase max, we see that it has remained under the 250 more or less. If we take a look at the final results, we see that actually it's in 259.6, which is slightly over the maximum goal that we set for it, but it's still good. And we can also take a look at the other iterations. So if we go to the analysis tab, we can see our objectives in vertical axis and the iterations connecting them. So if we see here, the maximum values are actually way out of the goal that we set, and that is because of the first random steps. But if we go down, in this case the in-phase maximum stress, if we move it down to the 250 maximum we selected, more or less there, and we zoom in, these are the iterations that keep the stress in the in-phase max under the 250. So we can click on some of them. For example, this one, it has it on 207.1 with a mass of 0.87, so that is quite high mass. But if we go to this one, for example, we'll have in 250.4 and the mass will be in 0.603. So we can right click on it, restore iteration, and the file will change with it. It's not very appreciable because it's really close to the point we are. Now we can just right click, auto range all axes, and go back to our original points. In order to check how the file has changed through the process, we can, for example, go to the extreme, the last iteration, restore iteration, and look how the file will look. This is the reason why the stress has gone so far, is because this connection has been thinned down too much, so the stress skyrocket. And if we go to the opposite point and restore iteration, we see that it happens the opposite. The connections have been thick up, and the smalls have gone really small, so obviously the stress is very small in this case. This has been everything for this video. It's been a short summary of how to set up an static optimization in Cortime, and I hope you enjoyed. Thank you very much.